find the area of the shaded region. Okay, so we can see that we're dealing with sectors, areas of sectors. So this is related to circles, as obviously we have a circle there. So we need to plug this into our formula that we have for the area of the sector. And remember, the formula is the angle over 360 times pi r squared. So let's do that. The angle is 300. That's what they tell us right here, that the angle of the sector is 300 over 360 times pi r squared. And r, they indicate right there, that's the radius. So pi 8 squared. So remember, this part right here deals with the circle, and this part right here tells us what proportion of the circle are we taking. Okay, so let's just plug this into our calculator to find out what this comes out to. Okay, so this came out to 167.55. And since they give us units on the diagram, let's use units here, centimeters squared. Since we're dealing with area of this region, it's going to be squared. Okay, so then the next one. Okay, so here we have two circles inside of a rectangle. Okay, so to find the shaded region, we're going to have to find the area of this rectangle and subtract out the area of these two circles. So you notice that the width of this rectangle is 6. So that means the diameter of the circle is also 6. That means that our radius of the circle is going to be 3. Okay, so that'll help us find the area of the circle. So let's just start calculating areas. So let's do the area of the rectangle. So we have 6 times 12 gives us the area of the rectangle, and we're going to subtract from that 2 times, because we have 2 of these small circles in there. The area of a circle is pi r squared, so pi 3 squared. Okay, so we need to plug this in the calculator and figure out some of the pieces. So we have 6 times 12 equals 72. Okay, so then we plug in the 2 times pi times 3 squared. And actually, if we were just to write this in terms of pi, we would have 3 squared is 9 times 2 is 18 pi. Okay. So let's plug in this line now into the calculator and kind of get a final answer for this area. Okay, so the area of the shaded region is 15.45 feet squared. Okay. Okay, let's take a look at the last one. Okay, this last one, we again are looking for the shaded region. So we have a circle, and then inside the circle is a hexagon. So we need to subtract out the area of the hexagon from the circle. So remember that for the hexagon, we actually, this is a special one. It gives us a shortcut because we know that this hexagon divides into equilateral triangles. And each one of the sides of these equilateral triangles is 4. So we do our special formula for the area of an equilateral triangle, and times 6 because there are 6 of those in this hexagon. So let's just set up our formula. So area equals, so let's find the area of the circle. We see the radius is 4, so pi 4 squared. So this is the area of the circle. Minus, so let's subtract out the area of the hexagon. So the formula for one triangle is 1/4 square root of 3 times s squared, which is side length, that's 4 squared, and then times 6 because there are 6 of these triangles. Okay, and so that's our hexagon here. So let's find each piece. So we have 16 pi here minus, so we have 4 squared, that's 16 over 4, that's 4 times 6 is 24 square root of 3. Okay, so that's how far we can do it without a calculator, so let's plug it in into our calculator and find a final answer. Okay, and I get for the area that it's 8.69, 8.7. And it says inches, so inches squared.